NASA's Webb just found hidden methane on an alien comet, and it could rewrite what we know about other solar systems. Imagine a frozen object traveling through the darkness between stars for millions, perhaps even billions of years. Now imagine that object entering our solar system and revealing chemical secrets never seen before. That is exactly what astronomers have discovered. Using the James Webb Space Telescope, NASA has detected methane for the very first time on an interstellar comet, a visitor that was born around another star and wandered across the galaxy before reaching our cosmic neighborhood. But that is only the beginning. This mysterious object, known as 3E Atlas, also contains unusually large amounts of carbon dioxide and displays a chemistry unlike almost any comet scientists have ever studied. Its strange composition may offer a rare glimpse into the birth of an entirely different planetary system, and it could change how we understand the formation of comets across the galaxy. Every comet is essentially a frozen time capsule. Locked inside its ice are molecules that preserve the conditions that existed when it first formed. Most comets we study originated in our own solar system more than 4.5 billion years ago, carrying ancient material from the era when the planets were just beginning to emerge. But 3 Atlas is different. It wasn't born near our sun. It formed around another star, making it only the third confirmed interstellar object ever discovered passing through our solar system. Unlike previous visitors, this comet gave scientists an extraordinary opportunity to directly analyze its chemical composition using one of the most powerful telescopes ever built. Das James Webb Space Telescope observed 3 Atlas using its mid-infrared instrument, known as MIRI. Rather than taking ordinary pictures, MIRI acts like a chemical detective. It separates infrared light into thousands of individual wavelengths, creating what scientists call a spectral fingerprint. Every molecule absorbs and emits light in its own unique pattern. By studying those patterns, researchers can determine exactly which chemicals surround the comet. In essence, Webb can identify the ingredients of an object hundreds of millions of kilometers away. Methane is one of the most volatile substances found in comets. Even modest warming causes frozen methane ice to rapidly transform into gas and escape into space. For that reason, scientists expected any surface methane to disappear long before Webb observed the comet. Yet, there it was. The first direct detection of methane ever recorded on an interstellar visitor. Its delayed appearance tells an interesting story. Researchers believe the comet's outer layers acted like insulation, protecting methane hidden deep inside the nucleus. Only after the comet passed close to the sun did solar heat gradually penetrate into these deeper layers. As the hidden ice warmed, methane finally escaped into space, revealing itself to Webb's instruments. It's almost as if the comet waited until the perfect moment to expose one of its oldest secrets. Scientists also discovered exceptionally high levels of carbon dioxide. Compared to water, the amount of carbon dioxide released by 3 Atlas is far greater than what astronomers typically observe in comets originating from our own solar system. Even more remarkable, the methane-to-water ratio is also unusually high. Only a handful of known solar system comets show anything remotely similar. Together, these measurements suggest that 3 Atlas formed in a completely different chemical environment. The region around its parent star likely contained a very different mixture of gases and ices than the cloud that produced our own sun and planets. In other words, this comet carries the chemical signature of an alien solar system. Webb also watched how the comet evolved as it traveled away from the sun. As expected, its overall activity declined. Water production dropped dramatically as temperatures cooled and less ice vaporized from the surface. Interestingly, methane and carbon dioxide behave differently. Because they are more volatile than water, their release followed different patterns. allowing researchers to study how various layers inside the comet respond to changing temperatures. These observations provide valuable clues about the comet's internal structure and the arrangement of its frozen materials. Instead of being chemically uniform, the comet appears to contain distinct layers formed during its ancient history. Its spectrometer functions as an integral field unit, allowing scientists to obtain a complete spectrum for every point across the comet's surrounding cloud of gas. Rather than producing a single chemical measurement, Webb creates a detailed map showing where different gases originate and how they spread into space. This gives researchers an unprecedented three-dimensional view of the comet's activity. It is like watching chemistry unfold in real time across an object that originated around another star. Because every interstellar visitor is a messenger from a distant planetary system, we cannot yet travel to those stars. But occasionally, nature sends us a sample. By studying objects like 3I Atlas, scientists gain direct evidence about how planets and comets form elsewhere in the galaxy. Each unexpected molecule, each unusual ratio of gases, and each hidden layer of ice helps build a larger picture of the incredible diversity of worlds beyond our own. The discovery of methane and the comet's unusual chemistry demonstrates just how powerful the James Webb Space Telescope has become. For the first time, humanity is not simply observing objects from other star systems. We are analyzing their chemical fingerprints, uncovering their histories, and comparing them with our own cosmic origins. As more interstellar visitors are discovered in the coming years, they may reveal even stranger chemistry and entirely new clues about the formation of planets throughout the Milky Way. A frozen traveler that spent millions of years drifting between stars has just reminded us that the universe still holds countless surprises, and we are only beginning to read the messages carried across the galaxy in